Hi, Assalamualaikum warahmatullahi wabarakatuh, and good day to every one of you. Okay, so in this video, we are still discussing on the application of second order differential equation in electrical circuit, particularly for two-loop RL circuit. Okay, so let's see the example of two-loop RL circuit. Okay, so it means that you are given a combination of series and parallel RL circuit. Okay, so the question here, derive two governing equation for the circuit above. So based on the circuit, there are two different mesh current, I1 and I2. So that's why here you need to derive the two governing equations. Okay, next, you need to show that the circuit can be modeled as d squared I2 over dt squared plus 12 di2 over dt plus 28 I2 equal to 40. Okay, so the solution to the question is, first of all, you need to redraw back the circuit. Okay, so since you have two different loops, so you need to apply KVL for the first loop and KVL for the second loop. Based on the mesh current, I1 and I2, we need to assign the polarity for each of the elements. So now we apply KVL for the left loop. Okay, so for the left loop, mesh current is given by I1. So the polarity of voltage for each of the passive element is given by this. Okay, so for supply, current is flow from negative to positive side, so that's why you have negative, positive E. And then for the passive elements of R1, L1 and R2, the current is flow from positive to negative, so that's why you have positive, negative VR1, positive, negative VL1 and positive, negative VR2. Okay, so according to the Kirchhoff voltage law, the total of voltage drop is equal to the total of voltage rise. So for voltage drop, you have VR1 plus VR2 plus VL1 equal to E. E is a voltage rise. Okay, so after that, we can just substitute the formula for each of the elements. We can apply Ohm's law. For VR is equal to IR, and then for R1, R is equal to 2 ohm. The mesh current is equal to I1. Okay, so that's why you have 2 I1. For R2, R is equal to 4 ohm. And for the mesh current that going through the R2 is equal to I1 minus I2. Okay, so that's why here you have 4 multiplied with I1 minus I2. For VL, VL is equal to L di over dt. So L is 1 Henry, I is I1. So that's why you have 1 multiplied with di1 over dt equal to E is equal to 20. Okay, here you have 20. So after that, we can further simplify the equation. So 2 plus 4 equal to 6. So 6I1 minus 4I2 plus di1 over dt equal to 20. So this is the first governing equation. So here you need to find the two governing equation, right? So let's do KVL for the right loop. So for right loop, you have mesh current I2. So based on this mesh current, we can assign the polarity for R3 and L2. So here we have positive, negative VR3, positive, negative VL2. Okay, so according to the Kirchhoff voltage law, total of voltage drop is equal to the total of voltage rise. So voltage drop is equal to VR3 plus VL2 equal to voltage rise is VR2. Okay, so after that, we can just substitute the formula for each of the term. So for VR is equal to IR, so R is equal to 8 ohm. I is equal to I2. Okay, the mesh current is I2 for R3. So that's why here you have 8 I2 plus VL is equal to L di over dt. So L is equal to 2 Henry. I is equal to I2. So di2 over dt equal to VR2. So again here, VR2 is equal to 4 multiplied with I1 minus I2. So that's why here you have 4 multiplied with I1 minus I2. Okay. After that, we can just rearrange the equation, bring all over this side to this side, so that you have 4I1 minus. So negative 4 minus negative 8, you have negative 12I2. So 2 di2 over dt, you bring to this side, you get negative 2 di2 over dt equal to 0. So this is the second governing equation. So you solve the first question already. So this is the first governing equation. This is the second governing equation. Next, we need to show that the circuit can be modeled as this ODE. Okay, so from equation number 2, we rearrange it so that we have 4i1 is equal to 12i2 plus 2 di2 over dt. And then from there, we simplify i1. So i1 become 12 divided by 4. So we got 3i2 plus 2 divided by 4. We got 1 over 2 di2 over dt. So this is considered as a equation 3. From here, we differentiate i1 over t to get di1 over dt is equal to 3 di2 over dt plus 1 over 2 d squared I2 over dt squared. Okay, so this is considered as equation 4. Okay, so now let's have a look at the given ODE. Okay, so if you notice, the only parameter that we have in the ODE is parameter I2 only. So here we have I2, and I2. So that's why from equation 1, you need to substitute the expression of I1 with I2. Okay, so how we do that? We can just substitute the equation 3 and equation 4 into equation 1. Okay, so 6I1 minus 4I2 plus di1 over dt equal to 20. Okay, so from here we can re-expand the equation so that we have 6 multiplied with 3, 18. 18 minus 4, we got 14i2 plus, okay, and then 6 multiplied with 1 over 2, we got 3 di2 over dt. 3 plus 3 is equal to 6 di2 over dt plus 1 over 2 d squared I2 over dt squared equal to 20. Okay, so from here you need to further simplify it so that you can only have d squared I2 over dt squared. So what we can do, we can multiply each of the term with 2. Okay, so we have d squared I2 over dt squared plus 6 multiplied with 2, you got 12 di2 over dt plus 14 we multiply with 2, you got 28 I2 equal to 20 multiplied with 2, you got 40. Okay, so it is shown that the circuit can be modeled by this ODE. Okay, so this ODE and this ODE is just the same. Alright. Okay, now we go to the next question. Question B. Solve the resulting differential equation by using method of undetermined coefficient. Okay, so based on the ODE, this ODE is a non-homogeneous equation. So we need to find the corresponding complementary function for the homogeneous equation. Okay, so the homogeneous equation is given by I2 double prime plus 12I2 prime plus 28I2 equal to 0. So from there, we just come up with the characteristic equation m squared plus 12m plus 28 equal to 0. So get your own calculator, try to solve it. So now my m is equal to negative 3.172 and negative 8.828. So this is considered as case 1 where your m is a real number and m1 is not equal to m2. So the solution is given by a exponent m1x plus b exponent m2x. So in this case, your expression is in t, so here is yt lah, should be yt. Okay, so now I2c is equal to a exponent negative 3.172t plus b exponent negative 8.828t. So next we need to find the particular integral. Okay, so let's have a look at the ODE. The fx is 40, so it's been considered as a polynomial type. So that's why your I2p is equal to a. So next, we need to compare your I2p with I2c. So here, your I2p doesn't have a same pattern with I2c. So this is the final I2p that we are going to use. Okay, so I2p is equal to a. So what is the value for a? So in order to find the value of a, we need to differentiate I2p 2 times. So I2p prime is equal to 0. I2p double prime is equal to 0. Okay. So lastly, we need to substitute the value of I2p double prime and I2p prime and I2p into the given ODE. Okay, so the given ODE is I2p double prime plus 12 I2p prime plus 28 I2p equal to 40. So we just substitute. So here is 0, here is 0. I2p is equal to a, so that's why we have 28 a equal to 40, so a is equal to 10 over 7. So now I2p is equal to 10 over 7. Okay, so finally, I2 is equal to I2c plus I2p. So here is my I2c and here is my I2p. So this is the general solution for the ODE. Okay, so that's all. Thanks for watching.